Mute it.
Problem here with the microphone.
Start presentation.
Yes, but our microphone is not working.
Now,
No,
are you sure?
I don't understand why, but it is not working.
To test the sound was. Yeah, it is working.
No, the sound is your mic is muted by your system settings. Go to your computer settings.
Who was in the room yesterday? You?
No, another one, another assistant.
Sound, yeah. And then only muted. Open your system. Open your system from there.
My
Yes,
system.
your laptop. So through that one, you will.
Okay,
Okay,
but
to the Google
we
Assistant.
can't do that because we are live stream via this computer, so I can't use mine. Provare il microfono. Ok, proviamo così.
You ask him when you see him.
No,
He can't see us as well.
I don't know. Can you hear us now? Va, Valentina, chi bisogna chiamare se non funziona il microfono? Can you hear us? Mr. Kumar? Dr. Kumar, can you hear us?
Can we start presentation?
Un mercante che non ha l'assistente. Ci vediamo tra poco.
Sì.
Nel caso devo subire le teste del computer più tardi.
Sì, certo.
What I'm saying, that can you open your system? So through you, we will connect from here.
How? I don't understand.
Hey,
this.
you have already on right here. You have already.
Yes, we are already on.
But we can control from the other system.
Yes.
It is already there.
Okay, 1 moment. Okay, no. What is the problem?
Okay, so you are chatting from there.
Yes, I am checking for assistance by the technician that knows the system,
So you have already. I mean, I'm just asking that are you sure that maybe his microphone has problem?
Yes, this is what I'm trying to understand. This is why I called for assistance by the technician of the Malaga University that knows this system and can help us. And
Yeah.
maybe can you ask to Dr. Kumar if he is using Firefox or Chrome? Maybe the problem.
That's why I
is-
open it. I'm calling to other presenter as well. So that's why I open from here.
Yeah,
He is saying that he is unmuted. In this room, there is no any problem. Okay, you can connect with the Wi-Fi. With the ADU down. You don't
Yes,
need-
yes. Can Are you an assistant? I can read it. Okay, can you help me with the microphones of this computer?
Okay.
Because it doesn't work, or at least the presenter doesn't hear us. So maybe it's a problem of the microphones. You can shut it down. Hello?
Yes. Check why.
Maybe, no?
Yes, microphones. They can't hear us, and we can't hear them. But I guess everything seems fine here.
No, not sure. Yeah, check it.
Click again.
Let's see. Hola. Hello. This is working. Hello.
Hello.
Yes.
Hello.
This is working.
Hi. Yes.
Yeah.
And the speakers too are working because I tried with the sound test.
Yes,
So
that's.
they are working.
Yes.
Maybe he has problem.
Maybe,
with something.
yeah, actually he uses yesterday. Maybe. Hello.
So he is unmuted.
Yeah.
Can we unmute it?
I'm muted?
I
No.
don't think so.
No, we can unmute it to him.
No. He has to unmute, it said.
Yeah, that's for safety.
Yes.
But this is blinking. I don't know if it's normal.
Yeah, it's all
normal.
well. Okay. Yeah.
Sorry.
Can they try to reconnect or
Yeah,
something
maybe it's a
similar?
good idea.
No, say no.
Ask her to go out and enter back. That's what they've done several
Yeah.
times with success.
It is not disconnect. Maybe restart the system.
Yes, it is. It's or
That's why I'm saying that if you connect as a login, we can test between you
yes.
and me.
Okay. Yeah. Yes. Yes.
That is
This was
until-
yeah.
I'm
Yes.
telling
I
you
know,
since
I
a
know.
long time,
Yes. Yes.
and you are not understanding my point.
I
I'm saying
know.
since beginning, open your laptop.
Yes, I'm
because-
doing. I understand. What I was trying to say was that the system looked fine, so maybe.
No, I know majority of the time their systems, they have the updates and
No, ahora no.
they have not updated their system,
Yo mi
Yeah.
and that's why their sound, this Windows are very problematic. If you are not updating your softwares, even time to time my laptop at the time of meeting,
A la portuguesa que sigue. Que le falta gente que siga, que se esté por mantener el programa. Así que está
Pero al final en la room de tenéis link en la room de
No,
y entonces ahí no hay nada.
que eliminar hasta la siguiente sesión.
Y pues
Testing.
Yeah.
Testing. We are testing the microphone.
hello. Hello.
Mi sentite? Sì.
Hello. Can you hear me? You can hear me? Can you hear me? Hello. Take your laptop out anywhere. Hello. Hello. Can you hear me? Hello. Can you hear me? Alfonso.
Speak again if you want.
You can hear me or not?
I can hear you.
Uh-huh.
I can hear him, but maybe we don't hear him in this.
You can hear him as well.
How about that?
No.
No, that's for
Oops.
turning. Oops.
Well, this guy has run away. You can hear the Sushil Kumar as well.
Yes, I heard him.
So ask him to present. We will
What
check
are his
from your
laptop?
system.
Why is red now?
Ask him to present if you can hear from here.
Yes,
Tell
I
him.
can.
No.
Can you hear us?
No, he is not hearing.
But he is not. Okay. Wow. I'm sorry.
Oh, don't worry. Let's try to, when it goes up, let's try to reset it. So
Yes. Anyone can hear us? Please give a feedback.
yes.
Yes.
Yes, unmute me.
I can hear you.
Yes, I can't unmute myself.
No.
Can you hear me? Hello. Yes.
The microphones. I mean, you should speak here.
But before I could hear Professor Sanjay speaking on my earphones, so the microphone was working, but and when I tried to speak, the voice echoed in the room, so the audio
It must
the
be
audio
a problem
system.
of the.
Maybe the problem is of the presenter, but I don't understand why. For instance, Love Kumar.
Hello.
Yes, I am here.
Hello. Yes. Hello. Is it coming here?
Okay.
Moderator.
Who is speaking? Who is speaking?
Why is not showing now?
Allora, Dr. Kumar, we are having some issues here. I don't know if you can hear us.
Yes, I can hear you. Your voice is
And
coming.
I'd like the other presenters, if they can hear us, to give us a feedback. We are trying to solve this technical issue.
Ask them to type.
Yeah, but I can see that
Dr. Kumar, can you hear us?
unmuted.
Yes, your voice is coming.
Okay, so can you, Dr. Kumar?
Yes.
Okay, you hear us? Can you hear Dr. Sushil Kumar?
Is he the presenter?
There are two people. So
Are there any missing people?
yeah, this one. Love Kumar is the last presenter. So, Dr. Sushil Kumar, can you hear me? Dr. Love Kumar, can you hear Dr. Sushil Kumar?
No.
You can hear only us. So the
Yes.
problem isn't ours. Okay.
In theory, I've been told to not to skip talks, just to wait and to honor the schedule. So,
Okay, yes, of course. But the second presenter is Dr. Sushil Kumar.
and now it's his turn.
He is here. He should start, but he can't hear us. I can't hear him. So
This
I
one,
will try.
we are talking to him, I suppose.
Yes, but he is the last one to present.
Okay.
If there is an issue with Sushil Kumar, then in this case, can I present first?
Okay, so Dr. Love Kumar, since we are experiencing some technical issues with Dr.
He can-
Sushil Kumar, if you are ready and if
You
you
can
want to
present.
start your presentation, the floor is yours.
Okay, fine. So I'm going to share my screen.
Yes?
No, we can't see your screen. We only
Yes.
can see you.
Okay,
Yes,
now we can see your screen.
yes.
Just 1 second. I'm going to share my PPT.
Suraj, share.
Yeah, that is fine. Sandhya, that is fine. I will see. No problem.
Yeah, it is
Okay.
okay. Go ahead.
I will go for the slide mode. Where is that option is there? Uh, yeah. Just 1 second, sir. I'm going to put in the slide mode. It is not coming. Just 1 second. Yes, sir. Can you please check my screen is visible or not? Hello.
Yeah.
Can you
Yes.
please check my screen is visible or not?
Yes. Go ahead.
Okay, fine. Yeah, fine. Okay, so good morning, everyone. So myself, Dr. Lapkumar from BITS Pilani Hyderabad campus. And this is a joint work with Chandramola, that is the BTech student, and also the Sandhya Vijay, that is also BTech student, and my colleague Lalit Bhanumurthy and Surinder Singh Samant. So the title of this paper is Software Sentiment Analysis Using Machine Learning with different word embedding techniques. Yeah. So these are the seminar outlines. So first we will discuss about the introduction, then we'll go for the study design. Then we'll discuss about our proposed framework, what types of framework we are using for software sentiment analysis, then experimental result, and finally we are also comparing the different types of technique, and finally we are making the conclusion with future work. So mainly the software sentiment analysis are basically used for the text data. So based on the text data, we are going to predict the sentiment of the user. But in this case, we are working for the software engineers. So based on the sentiment of the software developer, we have to find what is the sentiment behind this text. So when the software developer will give any types of comments related to the code, then based on the code, we have to use our model, and that model will predict what is the sentiment behind this, text. So here our main objective is to make the automation process, because manually it is not possible to find how many developer have given the positive sentiment and how many developers have given the negative sentiment. So that's why in this case our objective is to make one automation using machine learning technique, and that model will use to predict the sentiment of the software engineer based on the comments. So here our basic objective is to compare the predictive ability of different types of word embedding techniques, different types of feature selection technique, different types of sampling technique, and machine learning technique to classify the sentiment of the developer based on the comments. But these are the technical challenges when we have started working for the software sentiment analysis. The first one is word embedding technique, because when we are planning to use any type of machine learning technique, then in this case we have not used the directed text as a input. So first we have to convert the text to number. So here we are using the different types of word embedding technique to find what is the numerical representation of any text document, or what is the numerical representation of the developer comments. So here we have used the different types of word embedding technique, and the basic objective of this word embedding technique is only to convert the text data to numeric data. The next one is a high dimensional feature set, because when we are using the word embedding technique, we are getting the huge feature. In some case, we are getting approximately 700 feature. Some case we are also getting the 300 feature, but not all features are important for the sentiment analysis. So we are also using the different types of feature selection technique to find the important feature, or to find the feature that has the capability to distinguish between the positive and negative sentiment. The next one is imbalanced data. So what we observe like that, most of the cases we are not getting the equal distribution of positive and negative sentiment. So in this case, whatever the data we are getting, that is highly imbalanced. And if the data is highly imbalanced, then in this case we cannot use any type of machine learning technique. So here we are also using the data imbalance technique, that is basically used to balance the data, and after balancing the data we are going to use the different types of machine learning technique. So if you are going to check here, we have validated our proposed work using the three different types of data set. One is called the app review, second one is Jira, and third one is Stack Overflow. And here basically we have used the two different colors to represent the number of positive and negative sentiments. If you are going to check in the case of Stack Overflow, we are getting the mostly positive sentiment. If you are coming to the Jira, we are getting the positive as well as negative sentiment. If you are coming to the app review, here also we are getting the positive and negative sentiment. But in all the three cases, we are not getting the equal value of positive and negative sentiment. Means this one will directly represent that our data set is suffering from class imbalance problem. So directly we cannot use this data for the model prediction. First we have to balance the data, and after that we will go for the model development. So here we have used the different types of embedding technique, and here our main objective is to represent the textual data to the vector in n-dimensional space, or simple word we can say our main objective is to convert the textual data to numerical data. The first one we have used the most frequently used embedding technique, that is called the term frequency and inverse document frequency. So first we are going to find what are the total number of unique words present in the document, and then we are finding what is the frequency of the word, and if word have the good frequency, that we have considered as a one type of features. But in the case of term frequency and inverse document frequency, we can only find whether these two words are same or not. But we cannot make any conclusion like that, whether these two words are how much similar, that we cannot make the conclusion based on the term frequency and inverse document frequency. So that's why we have used the different types of embedding technique. One is called continuous bag of word. Second one is your skipgram. Then third one is global vector for word representation, then Google News word to vector, and then last one we have used the fast. So these embedding techniques, basically it will give the numerical representation of any word, and they have designed such a way that if we are going to find the word embedding of two similar words, we will also get the two similar representation of number. So they have designed the same like that. But in the case of term frequency and inverse document frequency, we can only say like that whether these two words are same or not, but we cannot find how much these two words are similar. That we cannot find by using the TF IDF. That's why we have used the different types of embedding techniques. Then after that, when we are applying the embedding technique, we are getting the set of vectors. So some case we are getting the 700 vectors, some case we are getting the 300 vectors, or indirectly we can also say like that, some case we are getting the 700 feature, 300 feature. In the case of TF-IDF, we are getting the 20,000 feature in the case of TF-IDF. But not all the features are important. So here basically we have applied the different types of feature selection. So first we have applied the ANOVA test to find that whether the single word has the capability to distinguish between the sentiment or not. So if we are getting any word, based on that, can we decide whether this word is related to the positive sentiment or whether this word is related to the negative sentiment. After that, we have also used the different types of feature selection technique. So once we found the significant feature and once we find what are the features that have the capability to distinguish between the positive and negative sentiment, then we are using the different types of feature selection technique. So here we have used the gain ratio, information gain, and 1R basically used as a feature ranking technique. So we have used this technique to rank all the feature, and after that we are selecting the top log 2 based in number of feature. But in the case of principal component analysis, we are also changing the value of the feature to get the better visualization of the data. That is called the principal component analysis. In the case of classifier attribute evaluation, we are finding the right subset of the feature. That is called the feature subset selection. But our main objective is to remove the irrelevant feature and select the best combination of right features. Then after that, we are using the different type of machine learning technique. We have used the general machine learning technique, and we have also used the assemble learning, because nowadays in some cases we are using the assemble learning, and that is giving the better result as compared to the most frequently used classifier. So as for example, here we have used the most frequently like multinomial naive-Bayes classifier, Bernoulli naive-Bayes classifier, Gaussian complete naive-Bayes classifier, KNN, decision tree, and support vector machine with the different kernel. These are the most frequently used classifier. But after that, we are also using the different type of assemble learning like bagging classifier, random forest classifier, extra tree classifier, AdaBoost classifier, and gradient boost classifier. And these all classifier were validated using the 5-fold cross validation to overcome the problem of overfitting and underfitting. So here what we have done in the 5-fold cross validation, first we have divided the data into the 5 equal parts, and at a time we are using the 4 parts data for the training and 1 part data for the testing. And we have continued this process 5 times. Then after that, we are comparing the performance of the model using the accuracy F measure and area under curve. Since our data is suffering from class imbalance problem, so here basically we are making the comparison based on the area under curve only. So this is the experimental setup. So first we are taking the developer comments, then we are using the different types of embedding technique to convert these comments to the numerical representation. After that, we are using the smooth and borderline smooth, that is basically used to balance the data. And once the data is balanced, then we are going to find the important feature by using the different types of feature selection technique. Once we got the relevant feature, then we are using the different types of machine learning technique. And here we have used the 2 different types of techniques. One is called the most frequently used classifier, and second one is called the assemble learning. And after that, we are comparing the performance of the model based on the accuracy, F measure, and area under curve. since our data is suffering from class imbalance problem, so here we are making the comparison, or here we are giving the more weightage to the area under. So this is the accuracy value for the original data. If we are not using any type of balanced data, if we are using the normal original data, then in this case, what is the area under curve? And if we are going to check here, most of the cases we are getting the area under curve greater than 0.75. And from the previous research, it was observed that if the model having the AUC value 0.75 means that model has the capability to predict the sentiment, or that model has the capability to predict the future. So here we are going to check in the case of assemble learning, we are getting the AUC value greater than 0.75. This one will represent that our model has the capability to predict a sentiment based on the user comments. And here we have also done for all the three data. Same like that, when we are using the smooth technique, then in this case we are getting the better value of AUC as compared to the original data. So if you are going to check, most of the cases we are getting the better value of AUC as compared to the original data. Then after that, we have also compared the work, which types of word embedding technique we will recommend to use for the software sentiment analysis, which types of classifier technique we will recommend to use for the software sentiment analysis, and also which types of assemble learning we will recommend to use for the software sentiment analysis. So here basically we have compared the different types of word embedding technique, and based on the AUC value we observed that the models developed by the feature expected from Globe and Google word to vector that have the better ability to predict sentiment as compared to other techniques. If we are going to compare with the TF-IDF, then in this case it is also giving the better result as compared to the TF-IDF with less number of features. After that, we have also applied the hypothesis test to check that if we are going to apply any type of embedding technique, can we say there is one significant improvement in the performance if we are changing the value of the embedding technique. So here we have applied the rank sum test, and also we have applied the Friedman test with our hypothesis like that the performance of the software sentiment analysis will not depend upon the embedding techniques. So in this case, if we are going to check, in most of the cases, we are getting the p-value less than 0.05. This will represent that the performance of the model totally depend upon the different types of embedding technique. If we are changing the embedding technique, definitely the performance of the model will change. But in out of this technique, which one is the best technique? So here we have also calculated the rank, and the lower value of rank basically represents the best. And here we observe that the Google word to vector have the lower rank, means if we are going to develop the software sentiment analysis using the feature that is extracted from Google word to vector, that will definitely give the better performance as compared to other embedding techniques. Then we have also compared the feature selection technique, and we are also comparing with the all feature, in which case we are getting the better feature, because in the all feature we are taking the very huge number of feature, and if we are going to remove the feature, then in this case basically we are getting the less number of features. So as for example, gain ratio, information gain, we are only taking the log 2 base n. If for the 1000 feature we are only taking the 10 best feature. So in this case, if we are going to check, if we are going to compare, then what we are getting like that, the models developed using the ANOVA, that is giving the little bit better result as compared to the all feature. Means this one will basically represent like that there is some irrelevant feature present in the all feature, and if we are going to remove those feature, the performance of the model will not change. But if we are taking only the 10 feature, top 10 feature, then in this case, the performance of the model will decrease. But if we are talking about the complexity wise, the complexity of the model will also decrease. So if we are using the cost benefit analysis, then definitely we will recommend to use these types of feature selection technique like gain ratio, information gain, 1R, and correlation attribute. Again, we have applied the same hypothesis testing here also, and here what we observe like that in the case of ANOVA, that is giving the similar types of performance as compared to the original data. Means if we are going to remove the irrelevant feature, or if we are going to remove the insignificant feature, then in this case the performance of the model will not change. And here we are also getting the p-value greater than 0.05, means this one will represent like that there is no any significance difference between the models developed using the all feature with the model developed using the significant feature. Both are almost same like that. If I am going for the gain ratio and PCA, in this case also we are getting greater than 0.05. This one will represent like that if we are going to develop the model with the selected set of feature using the information gain ratio, then in this case the performance of the model will not change. So in this case definitely we will recommend to use the ANOVA feature selection technique, because with the less number of feature we are getting the similar types of accuracy. Then after that, we are also comparing the different types of sampling technique. Here we have used the two different type of smooth technique. One is called a smooth and second one is called the borderline smooth. And we have compared the performance with the original data. And from this graph, we can easily observe that the smooth and borderline smooth, that is giving the better performance for sentiment analysis as compared to the original data. Again, when we are applying the hypothesis testing here, what we are getting like that, the models developed using or the model trained on the balanced data using the smooth and borderline smooth have significant improvement in the performance as compared to the original data. And if you are going for the different variant of a smooth, we will always recommend to use the simple smooth, because in the case of simple smooth, we are getting the better performance. Then after that, we are also comparing the different types of classification technique, in which case we are getting the better value of accuracy. So here, if we are going to check in the case of extra tree classifier, that is giving the better result as compared to the other classifier. If you are going to compare this result with the most frequently used classifier with the assemble learning, then assemble learning like bagging, random forest and extra tree classifier, those are giving the better result as compared to the normal classifier. Again, we have applied the same thing. We are also going to check if we are using the any type of assemble learning, can we say the performance of the model will improve or not? And here what we are observing like that, if we are using the assemble technique over the most frequently used classifier, then definitely the performance of the model will improve. And if we are going to recommend one assemble learning, then we will always recommend to use the extra tree classifier, because the model trained on the extra tree classifier, that is giving the better result for sentiment analysis as compared to the other assemble learning. So this is our final conclusion. So first one, the high value of the area under curve confirms that it is possible to predict the sentiment of the user based on the sentiment of the developer based on his comments. And the second one, if we are using the globe or Google word to factor as a feature extraction or as to find the numerical representation of the text, then in this case, our model will give the better result as compared to the TF-IDF or as compared to the COB and skip. The model trained using the extra tree classifier, that is giving the better result as compared to the most frequently used classifier or as compared to the other classifier. Then after that, again, if you are going for the feature selection technique, then in this case, we will always recommend to use the ANOVA test, because there is no any difference between the model developed on ANOVA and original data. In both the cases, we are getting the better result. So definitely we will recommend to use the ANOVA test. And then after that, the last conclusion, if we are going to use any type of data balancing technique, definitely the performance of the model will improve. So these are some selected references. If you have any question, then please ask.
So, Dr. Kumar, thank you very much for your presentation. Can you hear me?
Yes, yes.
Yes, okay. Thank you very much for your presentation. Are there any questions from the virtual room? Okay, so Dr. Sushil Kumar, do you have any questions? We can't still hear you. So if you have a question and you want to type a message in the chat box, we can proceed.
Which one? Anybody has asked any question to the lab?
At this moment, no. Maybe Dr. Sushil Kumar has a question, but we can't hear them. So
Now, what is your, I have a question. What is your
Yes,
major contribution in this work?
sir, your voice is not coming.
Yeah, I'm saying that what is the major contribution in this work? What is the major contribution?
Yes, sir. The major contribution is the first, sir. We have compared the different types of embedding technique, especially for the developer sentiment analysis. So there is no any such works like that where the author or researcher has compared the different types of embedding technique, or basically they have developed the model for the sentiment analysis for the developer. There is no any such models are there. Then the second contribution is our feature selection technique. We have also suggested which types of feature selection technique will help for the software sentiment analysis. Then third one, we have also compared the most frequently used classifier. If you are going for the sentiment analysis, mainly we are using the naive-based classifier. But what we observe like that, if we are using the assemble learning, that will give the better result as compared to the naive-based classifier. And the last one is your assemble this one sampling technique, because most of the cases we are going to simply ignore the data imbalance nature. But what we observe like that, if we are using the any type of imbalance technique, then definitely the performance of the model will improve. So these are our contributions.
Okay. So what is your what?
Sir, future, yes, sir, future work. Yeah, here, sir, what we are using some tools to find the word embedding. So in the future work, we are not planning to use the embedding in future work based on the sequence. Can we predict the sentiment or not? So we are not planning to find the numerical representation of a specific text. Directly, we have to take the sequence, and based on the sequence, we have to predict whether this is a positive sentiment or negative sentiment using the different variant of deep learning approach. That is our future work.
It's okay. Thank you so much.
Thank you, sir.
Very nice paper.
Thank you, sir. Thank you.
Okay, thank you, love. So be present and enjoy to the other papers.
Sure.
Next, Dr. Dharmendra Kumar is there. Dr. Ramesh, please unmute. Dr. Ramesh. Dr. Ramesh, he is the next presenter.
Yes,
And
yes,
Dr.
yes.
Present. And also, if what is Sushil Kumar is there, that is in the program, right?
Yes, yes,
Love has presented. He is the one.
yes.
Uh,
We have skipped before, and we have listened to Dr. Lokumar. And we have
Ramesh is there.
Sushil Kumar is here, but he can't
Okay.
speak, and Tan Guyan didn't show up.
Sure.
So
Yeah, he sent the slides, right? So please, Dr. Ramesh,
Dr. Ramesh, we can't unmute you, so you have to
You
go
have
to
to
the
unmute.
settings and select the unmute option. And then check also which microphone have you selected in your system. We can only ask to unmute, but we can't unmute him. Dr. Ramesh, can you hear us? Can you write in the chat box if you hear us?
Dr. Ramesh,
No, you are not. We can't hear you.
all of them they are present, but they cannot.
Yes, it's a shame. We had 4 presentations.
All of them there.
Yes, and we can't hear them.
Can I get a?
Yeah,
Can you provide me mic so this voice will not come out?
okay. I have only my. But
This is yours.
yes, this is the only one.
No, we are not even from the system.
No, there are no other earphones.
Because it is the last paper in this session.
Maybe it's not the best thing.
Yes, okay, because I don't want that they will clash.
No, Dr. Ramesh, we can't hear you. Can you hear us? Can you write in the chat if you can hear us? Dr. Ramesh, if you can hear us, you have to try to unmute your microphone. This is the icon, or otherwise, if the problem persists, you have to select this option and try with the settings and check which microphone has been selected. Okay, Dr. Nguyen, can you hear me? Can you unmute your microphone? Can you hear me? Please, can anyone among the participants tell me if you can hear me? If they can hear me?
Yes, I can hear you.
Okay, thank you very much, Dr. Lokmar.
Yeah.
Thank you very much, Dr. Yang. Dr. Nguyen, can you hear me? If you want, while Dr. Ramesh try to fix his technical problem, we can go on with your presentation. Dr. Ramesh, can you hear me? Dr. Ramesh, I see that your microphone is unmuted. Okay, we lost him. Dr. Nguyen, can you hear me? No, sincerely, I can't hear you. Dr. Sushil Kumar, can you hear us? Dr. Nguyen, can you hear us? Dr. Ramesh, can you hear us?
Wait up to 10 minutes, otherwise we can't do anything. Sam.
Okay.
Nobody
So,
is there, right?
we can't hear neither Dr. Nguyen nor Dr. Sushil Kumar, but Dr. Nguyen is sharing with us his presentation. So please go on, at least we can see your slides. Okay, thank you, Dr. Nguyen, for your presentation, even if it was muted and we couldn't hear you, but at least we were able to see your slide. Thank you very much. And now I have to close this session. I apologize. I am really sorry for all the technical issues that we have had, and I hope you will participate in the next session that will start at 10:30. So see you later. Thank you very much, and see you later. Good morning and welcome to this new session, session 5B, SEPA 2022 AM2. And we are ready to start in a few minutes. Can I ask to the first presenter, Dr. Jitao Yang, if they are present, if they can hear us, and to check their microphone to see if we can hear you.
Yes, hello, can you hear me?
Okay, we can hear you very well. Thank you very much. I can see
Okay.
also Professor Singh. Thank you very much. Can you hear us?
Yes. Thank you, sir. Thank you.
Okay, thank you very much. So, Professor Yang, whenever you are ready, if you like to start your presentation, or otherwise, if you prefer to wait a few minutes to see if other participants will join us. The choice
I'm
is
okay.
yours as well as the floor.
It depends on the chair. I'm available at any time for the presentation.
Okay. I welcome Professor Sanjay Misra, who is the chair of this session. Good morning, Professor. So, Dr. Yang, when you want to start, you can. The floor is yours. Thank you very much.
Okay. Okay. Now I will start my presentation, and the topic of the presentation is. Sorry.
Sorry, Professor Misra, we can hear you, but the audio is very, very distorted, so we can't understand you. Okay, please, the presenter, Professor Dr. Yang, please go on.
Okay. Okay, the topic of my presentation is the genetic data analysis and business process management platform for personalized nutrition service. Let's have a short introduction about the background. Since the traditional nutrient recommendations, commonly known as dietary reference index, estimated average daily nutrient intake levels to meet the requirements of a group of population. However, the difference of genetic background will affect the digestion, absorption, transport, metabolism, and storage of food and nutrients, and the steady state regulation of internal environment to varying degrees, reflecting the differences of different individuals' response to nutrition and susceptibility to disease. Therefore, we need to consider the nutrigenetics. And nutrigenetics can study how individuals' genetic composition affects diet response and susceptibility to diet-related diseases through a retrospective analysis of the interaction between individuals' genetic variations and diet, as well as diseases, such as individuals' dietary behaviors, vitamin and other nutritional needs, as well as metabolic fat regulation are all significantly different due to the composition of individuals' the genetic background. Such as genetic defects may cause the body to be unable to obtain nutrition from food. The health will be damaged. Therefore, it's necessary to evaluate nutrient requirements according to genetic composition so as to make more accurate nutritional supplementation. For example, nutrigenetics research shows that the genetic polymorphisms or multiple genes involved in vitamin D metabolic pathways affect the activation, transport, and absorption of vitamin D. Therefore, we need to analyze customers' genetic data. And to analyze the customer's genetic data, we provide a non-invasive and self-administered DNA collection solution through collecting customers' saliva. And after receiving the saliva from customer, our laboratory will extract the DNA from the saliva, and after a series of complex experimental processes, the DNA samples will be sequenced by different genome sequencing equipment such as iScan, NovaSeq, and ICCSA. And the sequencer will generate millions of reads data, and the gene sequencing data will be stored in cloud storage disks. There are multiple bioinformatic pipelines will analyze the reads data and give the genetic risk scores. And based on the genetic risk scores, the genetic interpretation system will generate genetic interpretation report using the gene disease associations databases. And this is the screenshot of our genetic interpretation report, and which was embedded in mobile phones. Since our customers are currently primarily in China, therefore the user interface is in Chinese. So those are the genetic testing items, such as the vitamin D nutrition requirement, vitamin A, B2, folic acid, and etc. So it's a list including more than 20 genetic testing items. And if the user click the name of the genetic testing item, more detailed information about the testing result will be opened in the second level page. And we all know that the genetic data is not enough for our personalized nutrition service. Therefore, we need to know more information about the customer. So to get customers' lifestyle data, we provide online food frequency questionnaires to collect customers' diet, sports, sleep, and other health-related data, including the questions related to health status or physical conditions, and the diet habits and the medical histories, and etc. Additionally, we provide an interface for customers to upload their physical examination report to our platform, including the physical examination data of heart rate, complete blood count, throat, ears, blood pressure, and etc. And therefore, we have three data sources, including the genetic testing data and the lifestyle data and the physical examination data. So this is the free user interface screenshots of the food frequency questionnaire. And the user can open it also in smartphones. And this is the physical examination report, that including the blood pressure data and etc. So therefore, currently we can combine the genetic testing data, lifestyle data, physical examination data together to analyze the personal nutrition requirement of different customer. So to analyze the data, we need to use bioinformatic algorithms, genetic interpretation algorithm, and nutrition requirement evaluation algorithm, so that to generate genetic interpretation reports and further generate personalized nutrition report. And based on the personalized nutrition report, our personalized nutrition intelligence service platform, in short, is the PNRS platform, can order smart manufacturing machine in nutrition factory directly to produce unique customized nutrition product for each customer. And this is the architecture of our personalized nutrition intelligent service platform that through the collection of multiple omics data, we use multiple different algorithms to analyze the data to generate the genetic interpretation report. And based on the report, we can compute personalized nutrition recommendation report. And further, we connect with the smart manufacturing factory so that we can produce a personalized product for each customer. And within the platform, the genome sequencing has, since the genome sequencing has multiple platforms, and therefore different sequencing platform requires different laboratory experimental methods and process, and generate the sequence state in different formats. So the PNIS platform can analyze tens of thousands of genetic testing samples in parallel. And bioinformatic analysis pipelines were implemented in cloud environment and scheduled by Kubernetes. And based on the nutrigenetics, dietary guidelines, population nutrition, big data, and customers' personal data, the PNIS will compute and give a personalized nutrition report for each person. And the personalized nutrition report includes two solutions. The first one is personalized customization product. The second one is personalized recommendation. And this is the user interface or the screenshots of the personalized nutrition report. So the first part, in the report, we will give the personalized nutrition supplements customization solution. And the product, we will produce personalized nutrition packs for each customer. And each customer's name will be printed on the pack. Also, on the pack, we will print the nutrients within the packs. Additionally, we will give the personalized food recommendations, such as that we will list which food is rich in which nutrients, such as to supplement vitamin D, we need to each such as the milk and etc. Like this different kind of foods. Additionally, to support the processing of large amounts of samples in parallel and the collaboration with multiple business partners, we develop several business process management systems, including the laboratory information management system, bioinformatic pipelines scheduling system, genetic interpretation system, personalized nutrition report system, production management system, online sales system, and customer relation management system. This is the system architecture of our business process management systems. So we can see that the systems are integrated together and can exchange data conveniently between each other. So our service provided support for business to business and business to customer service. In conclusion, currently most of the nutrition products are one size fits all, and the traditional nutrient recommendations are estimated to meet the requirements of a large group of population. However, the studies find that the genetic background will affect the digestion and the other metabolism and the storage of food and nutrients. And individuals' lifestyles and health conditions also have impact on individuals' nutrition requirement. Therefore, different individuals should supplement different kinds and different amounts of foods and nutrients. Based on nutrigenetics and nutriology, in this paper, we develop a personalized nutrition intelligence service platform. And the PNIS platform can collect individuals' genetic data through genetic testing and bioinformatic analysis, harvest lifestyle data through food frequency questionnaires, and retrieves individuals' physical examination data. And through bioinformatic analysis and genetic interpretation, PNIS platform generates genetic interpretation reports for each person and further combines lifestyle data and physical examination data to analyze and generate personalized nutrition reports. And based on the personalized nutrition report, the smart manufacturing nutrition factory will produce daily customized nutrition packs for each customer. Concerning future jobs, we will continue to optimize our personalized nutrition solution by analyzing more individuals' personal data, such as the sensor data of sports, sleep, and etc. Okay, thank you. This is my report. Any questions?
Thank you very much for your presentation, which was very, very interesting. And are there any questions from the audience? Okay, please, Professor Singh.
Yeah. So thank you so much for giving a very nice presentation. My only one query is your paper related to data. You will collect data from different sources. So what do you think that once you are collecting data, stuff, any kind of inconsistency, you can say, no?
I'm sorry, just now the voice, there's some problem. I cannot hear you clearly.
Yeah, my question is that how to reduce noise from the video.
No, I cannot. I cannot hear you clearly.
Sanjay ji, please close your mute your mic. So can you hear me now?
Yes.
Yeah. So my question is, how to collect your data so that you will get less noise from data, inconsistency. So your data will be high quality data. Only then you can get a better optimization. Also, you can get a good applications also. So once you are collecting data from different sources, so how do you take care of the noise and inconsistency from your data?
You mean the data consistency?
Yeah, and noise.
In fact, each customer need to register to our platform. Therefore, we will collect the data from each customer. How to say? We know the customer information, and we will the genetic testing data. We have the laboratory so that to implement the testing service. Therefore, we can know the genetic data, whose genetic data it is, and we also can ask the data fill their lifestyle data on our system. All the services are provided by our platform. Therefore, we can keep the data consistency easily. Since the lifestyle data are dynamic and the physical examination data are also dynamic. Therefore, we will keep the history data on our database. If we need to use them, we will retrieve them from our database.
So, okay, thank you so much. Thank you. So, another one small query is: you will take the primary data, or you will use some publicly available data for experiment?
Sorry.
So you will take the primary data, or you will use the publicly available data?
Not public data, we will private data. All the customers are our
Yeah, that's fine.
users.
That's fine.
Yes, yeah.
Okay, thank you. Congratulations. Thank you.
Encouragement. You are here, so you can just to chair the session as well. Professor Singh.
Yes, Mr. Ji. Good morning, sir. Good morning.
Good morning. I'm saying that you are here already, so you can chair the session as well.
Okay, no issue, no issue, no issue.
Okay. So go. You know the program or you don't know? My friend, he will assist you in the means inviting the paper, but you can ask the questions or we'll just moderate the
Yeah,
questions.
no
So
issue, no
call
issue.
to the next paper is from the love.
Yeah.
Again the love. No, I think Sandhya is presenting. Who is presenting? Sandhya.
I'll be presenting. Sanidhya.
Sandhya. Okay, please. Sandhya, start.
Okay.
And Professor VB Singh, if you have your papers ready, you can also ask the.
Yes, okay, yes. I'm asking my student to present also.
Yes. Because you can, if you can online, why not? So
Yeah,
just to at
yeah.
the end of the session, if there is
Sure.
a space.
Okay,
Right?
thank you.
So just to manage this one,
Sure, sir.
I'm
Sure.
managing in the 2 rooms. Yes. So Sandhya is
No
presenting.
issue,
Go ahead.
sir.
Thank you.
Thank you, sir.
Is my screen visible?
Yes.
Okay. So good morning to all present. I am Stanitha Vijayavargiya, a BTech student at BITS Pilani, Hyderabad campus, India. My co-authors for this paper are Dr. Lov Kumar, Professor Aruna Malapati, Professor Lalita Bhanumurthy, and Professor Sanjay
To
Mishra.
the calm clue, to the work, not to read the names of the authors. Go to the work.
Okay, so the title of our paper is Software Functional Requirements Classification Using Ensemble Learning. This is an overview of the various sections of the paper, which I will be covering in this presentation. In the introduction, we'll be covering the important concepts about the topic and why this work is needed. We will look at the study design used in the study, as well as the empirical research framework. Then we'll look at the experimental results, where we'll see the visual representation of the results using box plots and analyze the results statistically using Friedman testing. Finally, we will look at how this work can benefit future researchers. So, software requirements classification deals with segregating the client's requirements and demands found in the software requirements specification document, and we segregate them into functional and non-functional requirements. It is a key step in the software development pipeline, which can be automated using machine learning techniques. And the point of this is to allow the industry to save on labor expenses, because a domain expert is often required to perform this segregation. So functional requirements are the demands that the end user specifies as essential features that the system should provide. These are described as operations to be conducted, input to be delivered to the system, and the expected output. Non-functional requirements or quality requirements are the basic quality criteria that the system must meet, which includes aspects such as, for example, portability, maintainability, security, reliability, etc. A key program that needs to be addressed during requirements classification is that of the inconsistency in terminology used by the clients and the software engineers. This may lead to misclassification of the software requirements. The goal of this research is to provide a reliable and highly accurate machine learning model which can be deployed in the industry to classify the software requirements. To accomplish this, we've provided an extensive comparison of various word embedding techniques for the purpose of feature extraction, which is provided to analyze which technique is best suited for the software requirement specification document. We look at the effects of feature selection and dimensionality reduction on the performance of the models. Finally, we look at how 8 different ensemble classifiers perform on the chosen dataset to see which is the optimal classifier for software classification purposes. Since the dataset chosen contains an imbalance of classes, oversampling techniques have been used to provide better results. Some of the technical challenges that are faced in the software requirements classification revolve around choosing the right word embedding technique. Word embeddings help capture the information within the software requirement specification, and we this helps us get a numerical representation that we use as features for the rest of the machine learning pipeline. Thus, choosing the correct representation of the requirements is very important, and capturing the semantics of the text is key. Another major problem that has been faced in previous research is that of class imbalance in the data sets used for training these models. The dataset that is used to validate our models is the PROMISE dataset, which contains 625 labeled requirements taken from a group of 15 projects. The PROMISE repository is unbalanced in terms of functional and non-functional requirements, with 382 out of 625 being quality requirements. Cleland Huang and his team extracted this data with the help of students from DePaul University, and it was made available publicly. So for the word embedding techniques, we've used continuous bag of words, skipgram, word2vec, glove, and TF-IDF. Now, a point to note is that some of the word embedding techniques, such as TF-IDF, which is used here, are not able to capture the semantic information that is present. Thus, we've used pre-trained word embedding techniques like word-to-vector, glove, etc. And yeah. So moving on to feature selection. So we have done feature selection using rank sum test. And basically, when the data consists of two independent samples from two populations, the rank sum test can be used to test the null hypotheses that the distributions are identical. When the value of the test statistic is either considerably large or significantly small, the rank sum test can be used to reject the null hypotheses. And for dimensionality reduction, to remove irrelevant or redundant features, we've used principal component analysis. And so basically, what this helps do is we sacrifice the accuracy of the entire representative features for simplicity, so we can detect patterns that exist in the data. So ensemble learning techniques have been shown to produce some of the best results out of most classification techniques that are used. So in this paper, we are looking at a few ensemble classifiers and how their performances compared to each other and also previous research. And so we have the bag k nearest neighbors, bag decision tree, bag naive bias, random forest, extra tree, adaptive boosting, gradient boosting, and majority voting classifier. And as you can see, we've used multiple types of both bagging and boosting classifiers to see which uh, type of ensemble classifiers can produce the best results. So this is our research framework. So initially we have the software requirements, and
No, your screen is not visible.
We can't hear you. We can't see your presentation.
section with ranks and tests,
Okay.
and principal component analysis. And finally, we use the 8 different ensemble learning classifiers, and we perform analysis using multiple performance measures. So here are the performance measures, and we're looking at AUC primarily because of the imbalance of classes that exists in the data sets, in the data set. And here, as you can see, the left side is the original data, and the right side is after using the oversampling techniques, SMOT. And different columns show the different performance of the different classifiers, and we have the different word embedding techniques and the performance on the function and the qualitative data. And here are the feature selection or dimension reduction techniques. So similarly, we have it for skipgram, glove, etc. And what we can see is that SMOT, because it's easy to compare from the left to right, SMOT is giving much better performances compared to the original data. And yeah, and for further analysis, we have box plots and Friedman testing. And so as we can see from this box plot, you can see that TF-IDF and word to vector are TF-IDF seems to be better uh, when you're talking about the AUC values, and uh, which seems to have higher mean and higher median, and continuous bag of words clearly gives the worst performance out of all the word embedding techniques. And now we look at the Friedman test, which helps us decipher which is the best out of them all. And as we saw, TF-IDF has performed very well, but Word2Vec has the lowest mean rank. And what the mean rank does is that basically the lower the mean rank, the better is the performance. And in this case, we have used a p-value of 0.05 to determine the similarity between two models. And if the value is more than 0.05, we reject the null hypotheses. It's less than 0.0, we reject the null hypotheses. And so moving on to feature selection techniques. Here we have the accuracy, recall, precision, and AUC value comparisons. And from the box plot, it's easy to see that rank-sum test has outperformed all features, the original set of features, without the application of dimensionality reduction or feature selection, and PCA. And PCA has regressed the performance, as you can see. And basically, the Friedman test supports this observation. As we can, and again, rank sum test has a lower rank than all features, and thus it would be best for future researchers to use a feature selection technique of rank sum test rather than the original set of features. Again, the p-value for this was 0.05. Here is a visual comparison of the various classification techniques, ensemble classification techniques. And here we can see that majority voting classifier and bag k nearest neighbors have performed the best out of all the classifiers, and the boosting classifiers have shown worse performance compared to the others. And we can further look at the Friedman test to decipher which is the best classifier. And as we can see, the majority voting classifier is as well as the bagged KNN classifier. These two are performing very well, although the bagged KNN classifier performs marginally better than the majority voting ensemble classifier. Again, a p-value of 0.05 was used. Here's a comparison of the data with class balancing using oversampling with SMOTE, and the original data, which is represented as OD. And basically with the AUC comparison, we can see that SMOTE significantly improves the AUC values, thus indicating that balancing of classes is really important when it comes to software requirement classification. And here, the Friedman test supports observation, and thus we can conclude that SMOTE is clearly superior, and then and thus balanced data is very important for especially the data set we used. Moving on to conclusions, and as we saw with both the Friedman test and the box plots, word2vector and TF-IDF perform markedly better than other word embedding techniques. Although TF-IDF has much larger set of features than word2vector, so ideally word2vector should be preferred over TF-IDF. And the models that are trained using the majority voting ensemble classifier and the back KNN classifier produced the best performance out of all classifiers, and thus future researchers or future use in industry and all can employ these classifiers. And again, the features using rank sum tests were superior to all the other subset of features we looked at in the study, including the original set of features and the ones after dimensionality reduction with PCA. And as we saw, SMORT helped improve the performance of the requirements classification. And based on the findings of this experiment, ensemble classifiers are key to more accurate software requirements classification. That is all from my side. And these are the selected references. Any questions, please?
Thank you so much. So it's a binary problem or multi-class problem? Yeah.
Can you repeat the question?
Yeah. You are using which type of classification? It's a binary classification. What are the different class levels in your problem?
So basically, a software requirement, the data set is separated into functional requirements and non-functional requirements.
Oh, fine.
And each requirement is
Yeah,
either
you are
classified
getting requirements, and you are just classifying whether it is a functional or non-functional. Huh?
No. First, we the data set of functional and non-functional requirements. We separated into functional and non-functional separately, and so on the data sets, we trained the model detected whether the functional requirement was it a functional requirement or not, and on this other data set, it detected whether it's a non-functional requirement or not. So binary classification. Yeah.
Yeah, yes, but good.
Yeah, so just one second, sir. So some case, what will happen like that? Some requirements contain functional as well as non-functional. So that's why we are not using the binary. Some requirements containing both functional as well non-functional. So that's why we are developing the two different model. One model basically predict whether this is a functional requirement or not, and second model will predict whether this is a non-functional requirement or not. Something like that.
So it may also create some kind of class overlapping problem, I think.
Yes, sir.
Okay,
Yes, sir.
congratulations. Good work. Good work.
Yeah.
All the best. Thank you.
Yes.
So who is next one?
Authors, maybe you can ask to the authors to ask some questions. I can't ask because I'm co-author in this paper.
Your call.
Okay.
No, it's fine. So next presenter, it's good work. He has applied all the.
Next presentation is Sumit Babu and Raghuraj Singh.
He has taken care of everything. All the techniques of
Yes.
symbol and
Oh,
everything.
Love is a very hardworking and very productive student. Very, very hardworking. One of my best students. Yes.
Yeah. He's not left anything for other. He has taken care of everything. Good work.
Yes. So Sumit Babu, please.
Yes, sir. Good morning to all of you. My name is Sumit Babu, and my research paper topic is impact of inheritance and reusability.
Please share your screen. Please share your screen first.
So my name is Sumit Babu. Impact of my research paper title is Impact of Inheritance and Reusability on Design Quality of Object-Oriented Software. And I am presenting. My name is Sumit Babu. I am PhD research scholar in Harcourt Butler Technical University, India. So this is the content of my presentation. First of all, I will discuss introduction, then related work, and then my proposed work, and then I will discuss the two examples for illustration. Then I discuss the results and conclusion and future scope. So we all know that the inheritance is the main property of object-oriented paradigm. It mainly focuses on the attributes and methods that is shared among the different classes or modules in a hierarchical structure. So inheritance related to the reusability, they are directly dependent on each other. If the degree of inheritance is more in our module, then the reusability will be high. So inheritance means the usage of various attributes and methods among the different modules of a system. It is known as one of the valuable features in design quality of object-oriented software. So reusability is the main aspect in optimization of cost and time in software development. If we inherit that more attribute methods, classes, then the reusability index will be high. And these are provide more features like if the reusability is more than the reliability is high. So several metrics and models are exist which describe the impact of inheritance and reusability on different aspects of software. So several metrics and models are exist in this regards. So these are the some well-known metrics that are exist in related to the inheritance among the object-oriented software. So depth of inheritance tree, number of children are the most common, most well-known metrics that are proposed by Chidambar and Camera, and attribute inheritance factor and method inheritance factor are the metrics which is the ratio of attributes and methods. So inheritance coupling matrix is also a matrix related to the inheritance, and the depth of inheritance of tree of a class is proposed by Rajneesh Kumar, and this describes the total depth of the inheritance tree. And the next one is class inheritance tree. This matrix describes the inheritance in a class hierarchy, and other metrics are the derived base ratio, average number of direct child, average number of indirect child in relation to the different classes. And the latest method metrics are method complexity methods, message complexity matrix, attribute complexity, code complexity, and weighted class complexity. So these are the existing metrics related to inheritance and attribute method and so on. So in this work proposes a metric set of consisting five metrics to describe the impact of inheritance and reusability on design quality of object-oriented systems. So metrics related to inheritance and reusability has been proposed in this. The first four metrics related to inheritance and the last one is related to reusability. So main aspects related to the inheritance utility are identified and their impact on design of object-oriented system can be found. So we all know that the inheritance is caused by attributes, methods, classes, and the length and the depth of class hierarchy, which directly influence the inheritance or the other factors in object-oriented software. So first we consider attributes, method, classes, depth to calculate the degree of inheritance, and then we find the reusability using these metrics by assigning different weights. So the first matrix is inheritance class count matrix. This matrix is the ratio of number of inheritance classes to the all classes in the inheritance hierarchy. This matrix will identify all the classes or the number of parent and child classes that uh, inherit and inherited by other classes. So this is the ratio of the number of classes to the number of all classes. So this matrix gives the information about the number of classes that inherited property of other classes such as parent class, child class. So if a higher value of ICC matrix indicates that the more number of classes are involved in the inheritance and the reusability will be high. If ICC equal to 0, this means that no any class inherits the property of other class. If ICC equal to 1 means all classes inherit the properties of all classes, means all, all classes are connected to each other. And the next matrix is inherited attribute count. So this is the ratio of the inherited attribute to all attributes such as public, private, protected in the inheritance hierarchy. So IAC matrix gives information about the number of attributes that inherited by classes. If the value of IAC is higher, means that the more number of attributes are involved in the class hierarchy. If IAC is equal to 0, this means that no any attributes inherited by any other class attributes. And if if the value of IAC equal to B, this indicates that the class is very complex and difficult to maintain and understand, means that more maintainability and reliability is needed to manage this class. So next matrix is inherited method count. This matrix is the ratio of the inherited method to all other methods such as public, private, protected. So IMC matrix gives the information about the number of methods that are inherited by classes. If the value of IMC is high, means more number of methods are involved in the inheritance hierarchy. If value of IMC 0, then means no any class inherited by other class. So the next matrix is depth of inheritance hierarchy. This matrix is the distance of a node in the inheritance tree from which this node is inherited and defined as matrix node I into I. I is the ith level and L is the maximum level in the inheritance tree. This matrix gives the length from which a node is inherited. High value of DIG indicates that the inheritance hierarchy is high. High value of DIG indicates the design is very complex. So the next matrix is degree of reusability matrix. So first four matrices are based on inheritance and this matrix is based on reusability. By this matrix we can find the reusability degree of a class. So this matrix is defined as the W1 into ICC, W2 into IAC plus W3 into IAC and ratio of sum of all weights. These weights are will be decided as per the empirical data or expert opinion, and this matrix provides a scale of reusability in the design of object-oriented system. The low value of this matrix indicates that reusability may be less in the system, and high value indicates that the reusability high. The ICC matrix, IAC matrix, IMC, and DIS matrix directly affects the degree of reusability. For example, if more classes are involved in hierarchy, this indicates that the reusability will be high. If more number of attributes are involved in inheritance, they also affect the degree of reusability. And this is the same for method and depth of hierarchy. So these are we take two examples of low design and medium design for illustration. In this example, we take the hierarchy level 1, just for example, attribute class A, B, C, and attribute A methods M1, M2, M3. So in this figure, the value of IAC is zero point 0.3 because only one class is inherited out of three classes. IAC value has value zero point 0.3 because only one attribute is inherited out of three attributes, and similarly IMC is also zero point 0.3. The value of DIH is 1 because one class is inherited at level 1. The degree of reusability is 0.75 considering the simple average of the all metric values. So this is a more complex example. In this example, we take the hierarchy level 2. So in this figure, the value of ISC is 0.5 because three classes are inherited out of six classes. ISC matrix has value 0.57 because four attributes are inherited out of seven attributes. And so on IMC value is 0.2 and DIH of A is 5 because class A is inherited at level 1 and 2 and the DIH of B is 1. So the degree of reusability of this matrix is 1.81. So these are the results for both the design, low level design and medium level design, and this is the plot between the different metric values. So the result analysis is as per follows. So IAC matrix value of figure 1 is lower than that of figure 2, which means low level design has less impact of inheritance of classes. Similarly, IAC matrix value is lower for figure 1, which means that the inherited attributes have low impact in comparison to the high level design. So low IMC metric value for figure One means that inherited methods have low impact in comparison to high level. The result shows that if the design level is low, then the metric value is also low. If design level complex, then the metric values are more. So we consider two levels of design: low level design and medium level design. And in future, we will consider the high complex software projects for this metric set. So, in conclusion, so inheritance, reusability are the two main factors that affect the design quality of during the software development. Reusability depends on the depth of hierarchies. Inheritance depends on the use of predefined methods, attributes, classes, and the depth of hierarchy. So it is known that the reusability depends on the hierarchy. More degree of inheritance causes the increase in the degree of reusability. First four metrics focused on the inheritance, and the last fifth matrix is focused on the reusability. The low value of the degree of reusability matrix means less reusability. In the future, this work can be extended for the high level of design, such as bigger projects from industry or projects from different environments, and the metric value will be computed to validate its significance. So, and in future, we also plan to develop an automated tool to find the metric values. So these are the references. So thank you. Any questions?
So thank you, Sumit. Thank you so much. So what are the applications of all these matrices?
Well, sir, these metrics can be used to find the degree of inheritance and reusability. So uh, we can predict the the efforts needed to maintainability, reliability, understandability, such as.
Sir, have you gone through some papers who take care of all these matrices in understanding the reliability, maintainability of the software?
Yes, sir. So several metrics, several prediction models such as maintainability and reusability exist that uses the number and camera and other software metrics to find the degree of reusability, effort needed in maintainability. So we will try to develop a model by using our own metrics that will help in estimation.
So any other questions by any other participant?
Yeah, I have one question.
Yeah, please.
So, have you used the Viker property or not? Because when you are going to propose any type of matrix,
Yes, sir. Yes,
we
sir.
have to
So
use the Viker property to validate our proposed matrix. So, have you used the Viker property for the
so
validation?
in this work, we did not consider, and in future work, we will validate our metric set against the UCAS property. So UCAS 9 property will be validated against this metric set.
Okay.
Yeah, Professor Singh, I have one question.
Yes, please, sir, please.
Yeah, Sumit,
Yes,
uh,
sir.
are you masters or PhD student, if you don't mind?
Yes, sir.
Are you masters or bachelors or PhD student?
So I am a research scholar, PhD student.
PhD. Okay. So please discuss with me with this paper after the session as well, because what I can see that is you have not compared with the latest matrices. I have your paper as well. I'm chair of the session, so I can see the papers in the references. Most of them they are very old, 2010, 2003, 2000. There are several works going on, and you have to update yourself towards that one. Even Love, who asked you a question, he is one of the expert in software matrices.
Yes, sir. Yes, sir.
So, because there are several things which you have not considered, all those matrices, even though findings you are getting is almost, and even though I can show you the graph figure 3, they have the same tendency of the results. Means if they have the same tendency of the result, there is no any need to provide or propose a new matrix. And there are some frameworks which explains you and in which conditions and what are the factors you should consider when you are proposing a new metric, right? A framework for evaluation and validation of software matrices, how to validate your metrics. If you are not doing that one, means there is no any value of such matrices. So please contact, because it is a IEEE paper, am I right? So it is a IEEE paper and proceeding is not published yet. Please contact me, even though if I'm not replying in next 4 or 5 days, please contact me and improve your paper to the best of its level. So it may not, because I don't know that the guys who review your paper I'm not sure. Okay, so thank you so much, and we have. I hope that you are able to provide a very good paper, very good work on this one. VP Singh sir,
Thank you, Professor.
yes, there
So
is a chance that the last author is not present. If your first paper, previous paper can be presented at present, you are most welcome.
yeah, yeah. So Sushil, you want to present any other author?
Sushil, Sushil, please unmute and present your paper. Sushil, can you present? Can you come up? This is a problem since morning, sir. Even though I have called several technicians of this university because he is the first presenter since morning, yes. And they were fixing my
Please
system
unmute,
here.
unmute. Sushil, unmute.
He is doing since morning. If you have presentations, you can present it here. Sumit Babu, you are dear, sir. I am really.
Sir, I message you for providing mail ID.
We are not checking the mail ID. We are in the conference, so not all the time we are checking all the mails, and we are not responding to respond you within minutes.
Sorry, sir. Sorry.
Please present it. Can you present? Yes, yeah, no. Singh Saab, can you present?
Just I'm asking.
In absence of anything, we can close this session because there is no any author and we have a keynote. Please join to the keynote, and after afternoon session, we are going to meet at just to check the SEPA. And in the afternoon session, you are most welcome to join. In afternoon, today we have two sessions at 2:20 and 4:20. There are no parallel sessions, so I will be available.
So they can
So
present.
Mr. Just we can wait for 2-3 minutes. He's trying to present. Otherwise, we'll close the session.
So is there any chance that they can present now?
No, he's saying that he may get the slides in next.
So we'll not be able to present. So Professor Mishra, no, what to do next?
Yeah, you can share. You can share, sir.
No, he's trying to present. He's trying to present, right? Huh?
No, he can't present, sir. Since morning it is around 8:50. It is going to be 10:50.
Okay, so we'll meet tomorrow again, huh?
No, maybe tomorrow not possible, but it's okay. It's okay. Thank you, sir.
We'll meet tomorrow. I'll have to go again for some meeting, huh? Okay, thank you, sir. Thank you so much. Thank you.
Thank you, sir. Okay. So we are closing the sessions.
Yeah.
All the authors, please join to the session at 2:20. Check on the program. It is in room number I, but you can find the SEPA. Okay, you are welcome. All of you are welcome. Sushil Kumar, last chance. Can you present? Can you share your slide before we will close? Sushil Kumar. So we are leaving now. Thank you so much. Bye bye. So because the last of